Yeah, exactly. What's up, you scholars of enlightenment? So welcome back to another tech roundup. I am joined again by two excellent special guests. First of all, Ramsey Faragher, the real life James Bond Q. Ramsey, how are you this month? Good. Yeah, I'm glad it's a Friday too. Actually, it's been a very busy week. And second of all, Professor Jason Steffen, who is from the University of Las Vegas. He is an astronomer and has some knowledge of particle physics. A very strange beast. Jason, how are you? Jason, I saw that your queuing video. So, for those of you who are out there who might not be familiar with Jason, he's been on the channel a few times, but he had a paper a few years back, which was the best way to mathematically queue a plane. And I was thinking the other week that I might do a video about this, Jason. And then I looked to see if there was a video, and it's up to 15 million views. The video on your paper. CGP Grey apparently made a video which has got 439,000 upvotes and only 9,000 downvotes. So you did a good job. Yeah. It's always some like really weird, like I don't like planes or something, like nothing to do with the content of the video. So that's going great guns, but it ruined my plan for next week. But never mind. You know about that video, right? Okay. So hold up. Apparently, we're having a little problem with the sound. So let me fix that straight away. So that one is off. So can you try again?
Yeah, so uh,
I think that'll
there
fix it.
are,
So should we go? We'll go from the start again because
yeah,
apparently
start right
I
from the
messed up.
beginning.
I messed up the sound apparently. So now we can hear it. I'm just gonna do a little check to make sure everyone can hear. Um, Jason, if you could just say a few words.
Oh, yeah, my name is Jason Steffen. I am no, I'm not a distinguished professor. I foisted the wool over people's eyes and they got me a tenure track job.
Good. And now, Ramsey, just to check the sound is now working.
Hello, Sam. Hello, Jason. Hello, the whole world on YouTube.
How's
Hopefully,
that? How's that sound for you
fully
guys? Is
confirmed.
that sorted? Excellent.
Excellent.
Right. Good. We're
They're
good.
there.
Right. We'll go from the start again. So, what's up, you scholars of enlightenment? Welcome back to another tech roundup. I'm welcomed by two excellent special guests. First of all, Ramsey Faragher, who is the real life James Bond Q. Ramsey, how are you this month?
Very well, thank you, Sam, and I hope you are too.
I am very good. Thank you very much. And second of all, Professor Jason Steffen, who is a particle physicist and astrophysicist, now a professor of astronomy at the University of Las Vegas. And he's also, for you, those of you out there who don't know Jason, he wrote a paper on the optimal boarding method for airline passengers, the video for which is now up to 15 million views on YouTube. So that's maybe one of his claim to fame if you want to check that out. Jason, how are things going in your world this month?
Things are going really well. It's a little chilly. It's a little chilly. We're down to room temperature outside.
I was
So
going to say, does it get chilly in Las Vegas?
yeah, it does.
How cold does it get?
Well, so we're at like 70 degrees now, whatever that makes. Um,
Uh,
70 degrees, is that like 20? No.
20.
Yeah, probably about 20.
I mean, it's not cold, right? It's like, what is it here, Ramsey? Like 2 or something. It's getting
It
cold.
was below freezing this morning for me, so
Uh,
yeah, below 35.
So I even considered putting on long sleeves today.
I hate you. Right. Anyway, Jason, what is Astro 2020? Because I keep seeing it coming up on Twitter. A lot of people
Astro 2020,
whinging about it.
that
It
is the
sounds like some
document.
sort of sports event where like the planets get eliminated and they get Death Starred off one at a time.
Right.
What's going
So
on?
this is the decadal survey. Every 10 years, the National Academies puts together a survey of the basically astronomy as a whole. And they solicit white papers. It's a multi-year project. It's probably 5 years, honestly, in the making.
Are you
in terms
allowed?
of
Are you allowed to
selecting
solicit
your
white
committee.
papers anymore? Is this
Yeah. So
something
they
that's,
solicit. They
sounds
send.
non-inclusive, Jason?
No. They send out a big advertisement that says, "We're going to do the decadal survey. Send in your white papers, like suggestions and things like that." And then big committees. I mean, like probably of order 100 scientists are on these committees, putting things together, saying, "Here's all the papers that are related to exoplanets. Here's all the papers that are related to cosmology. Here's all the papers that are related to astrophysics that nobody really cares about." Because those are basically the three options, right? I'm just kidding. But they have this. They solicit all these white papers. They bring them in, then they synthesize everything and come up with, here are the suggestions for not only science topics that people should address. What are the main missions that NASA should focus on, or the National Science Foundation? But also, are there concerns in, say, the grant programs? Are there concerns that, and this is definitely true, I believe this time around, I haven't read the whole thing, it's hundreds of pages, and it was true last time as well, that they said the big projects are they're undercutting the small grants programs, which is where a lot of the innovation really comes, like professors and their graduate students.
So it's sort of like a meeting, like a brains trust to look at sort of the current state of astronomy, how we can do better, this kind of thing. Is that fair?
Yeah, it's the state of the field, and it's designed to say, okay, here are the issues that we're dealing with that should be corrected, and here's recommendations. So they have a list of recommendations about, given the state of the science and the state of the technology, what are the most promising missions? There was a change with the 2010 decadal survey where they had other constraints. They added a component where they had to do better costing, because I guess the 2020 decadal survey had wildly underestimated the cost for some of the missions that were proposed. And when it came to light, it was like, wow, this we need to change the way that we do that. So it's kind of an ongoing process. I don't know how many decadal surveys there have been, probably of order 10. But it may be less than that. I'm not sure. But anyways, it comes out. This is the 2020 decadal survey. So we can look forward to not only reading this, it's also something that you use when you're writing grant proposals. You know, you'll say, this falls in line with these suggestions from the decadal survey. So it's a book of scripture that you can invoke.
So you're in line with the higher ups.
Yeah, and you know, if you're petitioning the government for redress of grievances, which we are supposed to have a constitutional right to do, if you say, you know, we should have science funding, and here's what the recommendations are for from the astronomy community about what that funding should go towards. So when you write your congressman about a bill that comes up, you can advocate for it and point to. So it does shape science policy. And I think they do this as well in particle physics. Is it P5? The particle physics planning program. So it's the P5 report. I think they come out, I don't know if it's every 5 years or every 10 years as well. So every scientific discipline should have this, but of course they should listen to the astronomers and physicists more than anybody else.
That goes without saying. And I want to come on to, for the first topic, this idea, and it is an astronomy topic. And I'm sure both of you have seen this week, that we may have discovered a planet in another galaxy. So Jason, have you seen this? What did you make of this?
I saw the article. I didn't have a chance to read it in a lot of detail.
I can give an overview then. So the idea is that astronomers may have discovered a planet in another galaxy. This is the 28 million light years away Whirlpool galaxy, where there's a bright X-ray binary called M51 ULS1. They're always, beautifully named. And in the system, it hosts a black hole, which is likely feeding off another massive bright blue star. And the idea of what's happened is the accretion disk of the black hole gets very, very hot as the gas spirals in towards the black hole, gives off a lot of X-ray light. And what scientists believe they have seen is essentially the transit of a planet which has gone in front of part of that accretion disk and blocked out some of the light. So they now believe that they've seen the transit of a planet in front of a black hole in another galaxy. So this would be the first candidate, what they're calling an extrasolar planet. So a planet in another galaxy. So any thoughts now that's a summary, Jason.
Yeah, so this has been anticipated that we would find, I'm going to call them extragalactic. Well, I don't know. I'm really hesitant to add new language, like new words to the dictionary. So an exoplanet.
Extrasolar, they've been calling them instead of extra.
Yeah, I don't know.
I immediately thought of extragalactic.
So I'll call it.
Why didn't they go straight for extragalactic? It makes much more sense. It does. It's the first one that popped into my head as well.
Yeah, I don't really understand, to be honest.
I maybe could be convinced of the naming convention, but in general, I'm like, we should be very careful about adding new words to the language. But anyways, so an extragalactic extrasolar planet. This was anticipated. One, I saw a paper written by a friend of mine who looked at LSST as a means of finding transiting planets in the Large Magellanic Cloud, which is a satellite galaxy, but it's a separate entity, basically using the transit method as well. So they did estimates for what they would find. In this case, because the Whirlpool Galaxy isn't our nearest neighbor, and as soon as I saw that it was an X-ray source, it kind of made sense as to why it would be an X-ray source, because they wouldn't be able to resolve an individual star within the galaxy. The pixels are way too small. But with X-ray sources, because they're more spread out, I don't know how many X-ray sources there are in the Whirlpool Galaxy, but it's probably enough or not sufficient to
not so dense that they all kind of overlap with one another.
Right. And so you know that they're individual sources. And so then seeing the transit, the duration was a few hours, which is a typical transit duration. So yeah, it all hangs together in terms of this would be a realistic signal that you would expect to find, or that one could expect to find.
How useful is this? Because it strikes me, and I had a chat with a couple of astronomer people. I had a chat with Jackie Farty, who's over in New York. And she was saying, look, it's really interesting. It's a cool headline for people to look at a video on YouTube or whatever it might be. But the planets that you'll be able to detect with this method are presumably very, very niche. We've got a black hole with an orbiting star, and then somehow there's a planet hanging around. I don't know how many systems look like this. And then you've got to catch the transit exactly. You've got to have the right orientation, the right timing of looking at that transit. It seems like you're going to find very niche planets this way. So it's more like it's a nice tech demo. It's good to see that physics sort of operates the same way in another galaxy, and we're seeing these planets there. But how useful is it from a kind of scientific perspective going forward?
I think it depends on what you mean by useful. So the first planets that were ever discovered were around a neutron star.
Yeah,
and
that's true.
So it shows like planet formation is a ubiquitous thing. So what is useful in terms of like what's the scientific? I can imagine that 50 years from now we might know of a half a dozen of these, something like that. So it's not really something where you're going to do a population synthesis model, although all it takes is one data point to place a constraint on things.
There'll be enough papers coming out of this trying to project from a tiny niche sample. But
at the same time, if this is the thing that inspires someone to major in physics and to devote their intellect towards developing a nuclear reactor that saves the planet, then it's worth it.
Yeah.
So there is, I think that there is some role for water cooler fodder, people to discuss and be interested in science, and this serves that purpose. And that's an advantage that you have in astronomy, that a lot of the discoveries produce, it's really quite awe-inspiring, the kinds of discoveries that astronomy gets to make. And so things that keep the population interested in science, engaged, especially when it's not as politicized as some other disciplines might be.
Yeah, I think that's a really good point to make. We should point out just while we're doing this, it's a candidate planet, so it's not necessarily, or it's not certain that they have seen a planet. So it could be something else.
Could be something else.
Yeah, they tried to rule out a lot of other things, like I think they tried to rule out a. Well, yeah, yes, they tried to rule out a massive UAP. What else did they try to rule out? They tried to rule out
alien megastructures.
Yeah, white dwarfs, which they say would have lensed the light, and therefore,
would have lensed it.
Yeah, we would have expected more magnification. What else did they say? They tried a set of they tried the hypothesis of a gas cloud, but you would have expected all the sort of light to dim
differently,
different wavelengths depending on the exact characteristics of the gas cloud, and that's not what they saw.
So if they saw the same shape in all wavelengths, then it pretty much has to be a totally opaque object.
Yeah. Which only leaves us planet and Death Star. Yeah. And then there's
it could be a moon. It could be a moon. No.
Dave, you'll get Dave too excited if it's a moon.
Or a space station.
Yeah. So the thing that they can't quite get at is how close is it to this system? Obviously, it can't be too close. It's going to get ripped apart by the tidal forces of the black hole and the star. But obviously, you have a situation where it could be closer and smaller, or further out and bigger.
Was it a single transit?
Or is it closer? No, closer and bigger, or further out and smaller. I'm trying to think of what will it be? So if it's bigger and closer, it's going to block out more of the light. Yeah. So it can be, depending on how far it is away from the accretion disk part that it's blocking, it could be of different sizes. So they're not exactly sure how big this planet is, but they think it's around the size of Jupiter, less than the size of Jupiter.
Let's see, what is the I'll look up the data just to see. I'm curious how many transits they found. It may have only been one.
I think they only saw one, and this is one of the other problems, is that if it's as far out as they think it is, they won't see another transit for a long time. So not only is it,
and it would have to be continuously monitored.
Exactly.
Because it's only a couple hours long. So so they can estimate the orbital period based on the duration. If they assume the mass of whatever the central body is, then you can estimate the orbital period based on the duration. But that implies a circular orbit.
Yeah.
And so if the orbit is not circular, then you can have there can be a fairly large variation in the duration of the transit.
Yeah.
And so as a consequence, you don't necessarily know the orbital period.
Yeah.
But this looks like what you'd expect. And if it's independent of, so this is kiloseconds, what do they got? It looks like 1, 2, 3, 4, 5, 6 kiloseconds. That's 15 minutes times 6 is an hour and a half. Yeah, this is all, it all hangs together as a
sensible transit duration.
Yeah.
How many of these sort of systems would you expect to see? Because me, just very naively as a non-expert looking at it, I was like, there's a black hole and a blue giant or a similar star, and then there's just a planet which is seemingly quite happy about being in the system. Naively, to me, it seems like it'd be ripped apart or ejected or on some sort of highly eccentric orbit.
These are probably fairly common, to be honest, because it's obviously not every star. You have to have a star that's massive enough to become a black hole or neutron star. I'm not sure what the central body is. These often come in binaries, like the stars come in binaries. So you have one star that blows up, the other one goes into its late stage of evolution. The older star that died first starts pulling material off of the nearby star that forms an accretion disk. And then, so I would, only based upon what I know, which is 10 minutes of discussion, I suspect that this planet formed from the accretion disk.
Yeah.
So it's a second generation planet. The first generation of planets were probably destroyed. The second generation of planets would form. You can have planets that survive.
It's not a good life candidate. Let's say
so life is probably not a thing. It's only if it has this hour and a half duration, depending on the orientation and what that implies for how big the orbit actually is, you could imagine having something the size of Jupiter actually survive. But that puts its orbit at like 20 years, 20 or 30 years, as opposed to, and at a 20-year orbit, you're looking at a half a day, like a 10-hour transit or something like that, instead of a 1-hour transit. So that makes me think if it's on a circular orbit, then its orbit is only a few days long. And that would be a second generation planet that formed from the accretion disk itself. And that's basically what happened with the pulsar planets that have been found, is They're millisecond pulsars, which implies that there was a nearby star that sped up the pulsar, and in the process of doing so, you had an accretion disk from which the planets formed.
So I wanted to kind of move this on. So very, very interesting. So how many exoplanets? So thinking in this. So this is the first, and I don't want to bring the words back in, but extrasolar, or extragalactic planet in another galaxy. How many exoplanets and exoplanet candidates have we got in this galaxy now? What are we up to?
It's about 5,000.
About 5,000.
Yeah.
And we've got the other big thing, of course, that's going on in astronomy at the moment is James Webb's coming online. So what status are we at with that now? So maybe if you could tell us a little bit about what James Webb is designed to do, because it's going to launch relatively soon, and why the hell it's taken so long. Because it always seems to be that one that's sort of 6 months away, or it certainly has been since I was doing PhD.
Yeah,
it's been
20 years ago they were talking about launching. Yeah.
So okay, so a lot of things about James Webb. I guess the James Webb is not a survey instrument. It's it's a small field of view type instrument. It's designed to look primarily in the infrared. That's why the mirrors are gold covered instead of silver, because you get better reflection properties in the infrared. It's a bigger telescope than Hubble, but the angular resolution that it will have, like the size of features that it will be able to resolve, is fairly similar to Hubble, because Hubble was in visible light. It was a smaller telescope in visible light. This is a bigger telescope, but it's longer wavelength.
Right.
And so you still have the same diffraction spot. The ratio of the wavelength to the diameter is basically the same.
So it's going to be it's essentially the successor to Hubble. Is that fair to say? Yeah.
And they want it in the infrared because Hubble's already taken, we have a lot of information from Hubble on visible light astronomy. The infrared allows you to see through dust more readily. You can't see through all dust, but you can see deeper into dust lanes and things like that. Star forming regions. Also, when you're talking about cosmology and you're looking at galaxies that are redshifted. So if you have a redshift of 2, for example, now all of a sudden what was visible light astronomy to nearby galaxies turns into infrared astronomy for distant galaxies.
Yeah.
And so
you can look out further and therefore further back in time, I guess.
Yeah, so you'll study the same features, except you'll have the sensitivity to the same features, except at a distance that is farther away, which implies an earlier stage in the formation of the life cycle of the galaxy. So that's what James Webb will do. As far as exoplanets are concerned, it will be a really good instrument for studying atmospheres, thermal properties of extrasolar planets.
Because you can get these IR fingerprints, you can get, I guess, the vibrational spectra of the molecules in the atmosphere, right? So.
Yeah, so when you have molecules in the atmosphere, the floppier the molecules are, the more infrared signatures they'll have. So water is fairly floppy. Methane is pretty
floppy.
Carbon
dioxide, things like this.
Yeah. Once you get past two atoms in the molecule, then the infrared signature comes out. That's
they got all these nice different vibrational modes that you can excite.
It does the hula hoop mode, and that's basically what a greenhouse gas does, right? The reason greenhouse gases are what they are is because they can do the hula hoop mode. There's different vibration states that they have that you don't have with the dumbbell, with the oxygen and nitrogen that just have 2 atoms.
Ramsey, you worked were you ever in infrared?
No, all my stuff was radio.
All your stuff was radio.
So much on the wavelength, but punches through stuff much better.
That's when we can get super, super, super far back. But,
well, that's how you can see planets that are.
Yeah.
I guess this was an X-ray source though, so I suspect it probably has a large radio signature as well, though.
So the second part of this. Sorry, Ramsey, were you going to say something then?
Yeah, just on the tech side of the James Webb Telescope, I think one of the reasons it's taken so long as well to launch, not only has there been controversies and delays and overruns and all the usual things, but there's a phenomenal amount of complicated processes involved in the launch, isn't it? I was reading something about how, like,
350 individual points of failure or something silly I read.
Yeah, so when they unfold the origami shield, it's something like the strapline has been when people land a rover on Mars, they talk about the 8 minutes of terror or whatever as it's entering and landing. And it's something like 11 months of terror as they do all of these 350. Have you seen this, Jason? Do you come across this?
I've watched some animations of how it's going to play out. And yeah, the heat shield was definitely something. There's other things like just unfolding the telescope in general. So there's a lot of technology. And the challenge that you face with these kinds of instruments can also come down to when you write your specification. As soon as you say as good as you can, then the contractor's like, hey, I can drive a very large train of money through that hole right there. But there's also the issue of, well, over the course of the development, we've had 2 recessions, and it was sucking up all sorts of money. They actually had to switch it so that it had its own line item because it was taking up so much money out of the other NASA programs.
What's the budget now compared to the budget that was slated for it?
Probably like a factor of 10 more, like 5 to 10 more than it.
What are the absolutes?
I think it's 10 billion. I think it was supposed to be 1.2 billion or something like that. Now, I will say one thing that the public should know about these kinds of projects is when there's funding that gets cut to a program. So this basically comes down to like 2008. They did the omnibus bill that went through, and they're like, oh my gosh, we just sliced all of the funding to all these things. When that happens, everything becomes instantly more expensive, because when you take a NASA program and you say, okay, NASA, your budget has now been reduced by 10% or something like that, that 10% doesn't come out of the air conditioning. It doesn't come out of the personnel. It comes out of the money that gets devoted to different projects. And so now all of a sudden, it might be a 10% reduction to NASA as a whole, but it could be a 70% reduction to a particular project.
Squeeze.
And so now you're trying to build something off of, with less money to buy the material to build it with. And so now it takes longer to build it. And so while one may think that with these kinds of projects that they're saving money by reducing the budget, what it does is it actually increases the cost of any individual
and
thing.
Spreads it out over a longer time period.
Because had they just been like, I mean, there's a lot of testing, so it's not like they could have immediately shaved off a decade, but pretty close. You could have probably shaved off 8 years if they had the resources to put into it back around 2008 when things were getting off the ground and all of a sudden the budget cuts went into place. So like these are economics is not a trivial thing.
I was just frantically Googling if it's the most overrunning space program of all time. Galileo, the Galileo satellite constellation is like well over 10 years late in terms of being fully finished. And I don't know the exact numbers, but they were definitely talking about the James Webb telescope when I was a student 20 years ago. So
it's been on the radar. And this is one of the things I think that came out of like we need to make sure with the decadal survey that we have an outside company that audits the proposals so that they have at least a second opinion on what's the budget for these different missions.
I'll tell you one of the most amazing things as well, that Hubble has lasted so long. Like some of the stuff we chuck up there really lasts a long time. There's Martian rovers that are 10 years older than they're supposed to be. And Hubble's kind of in the process of dying, right? I remember seeing things about bits of Hubble.
So they're not going to do another servicing mission. It could last longer, right? They could take up another camera. They would have a challenge because the shuttle isn't there anymore. And so the mission that they would normally use for repairs.
Jeff wants some work, doesn't he, in space? Send Jeff.
So, but Hubble's, it's certainly had a long run, but part of that is because they were able to go up and service it. They've replaced the camera. One of the challenges so James Webb will not be refurbished. It'll fly. They'll use it as long as they possibly can. But once it's done, there's no going back because it's going to a much different location.
It's a Lagrange point, is it? From memory, is that right?
L2. So
we're not going to send any service modules out there.
That's a bit far.
How far out are we talking with that? Just so people watching can.
Oh, about yay far.
So it's like completely.
So where is it? Where is L2? I'm trying to think.
So if like the sun's here,
Yeah.
we're at one of my fingers, and the other two are the Lagrange points. Is that or is it different?
No, it's
is it
the
different Lagrange
inline.
points
It's the inline Lagrange points.
to the moon?
So it's
The inline one to the moon.
no, it's the one to. It's the Earth Lagrange point. So there are 5 Lagrange points altogether.
I'm getting Euler mechanics flashbacks from like year
Right.
2.
So there's 2 Lagrange points that are the stable Lagrange points, and those are in the orbit. So they're 60 degrees advanced and 60 degrees retarded from the orbit of the planet. And then there's 3 Lagrange points that are the unstable Lagrange points. One of them is exactly opposite the planet, and then the other 2 surround the planet. It has to do with the cube root of the mass ratio of the thing times its major axis, something like that. So what would the cube root be? So that would be.
I'll put a little cartoon up for people afterwards. I'll cut it.
I suspect it's probably like a tenth of an AU. It's probably like a tenth of an AU, something like that. So it's way farther than low Earth orbit, which is.
You're going to need more than a box of sandwiches to get there.
Yeah, a lot of toilet paper.
Ramsey was talking about the fact that we keep these things going for a long time. What's the Exoplanet mission that's been running for absolutely ages, and it was supposed to run and die, and they kept it going for ages. You'll know the
well, so Kepler,
yeah.
So that one was supposed to run for 4 years, or like 3.5 years, and it lasted for 4 years in its nominal phase. Then some reaction wheels failed, so that one failed through some mechanical devices. Had the reaction wheel remained working, it would have gone for a whole decade without any trouble. It went for 9 years, which is basically a whole decade. But it has expendables. It has like thruster fuel that run out, and at that point, then they can't control it anymore. When it comes to the infrared missions, like James Webb, it's got a lifetime that's dictated by the coolant. So they're launching up, they have to cool the instrument down because they're looking at long wavelengths, which means that you get signals from all sorts of places that heat, this coolant's boiling away the whole time. And once the coolant boils away, then the instrument heats up, and now it's not as sensitive anymore.
And I'm guessing this is because the photons that are coming in, the IR photons, are low energy. So you've got to keep that signal to noise ratio incredibly
your
low.
Noise temperature has to be below the signal temperature.
They said, what is it, kept below 50 Kelvin by this huge heat shield which is on the back, and like you say, a load of coolant. So has to be incredibly low interference. And you'll know this, Ramsey, from working with lots of sensors. If there's any heat there, any thermal noise, it's going to just swamp the infrared photons, which are very low energy, coming in. So it has to be kept very, very cold and shielded from other radiation sources, which is why it has this big set of unfolding mirrors that you can see in the picture. So apparently that's why it's got to unfold, and it might go wrong at any moment, and we'll have to see how that goes. Yes.
Yeah, and let's hope they get the optics right, which they didn't with Hubble, right? Because as we just discussed, we won't be able to send up. So your audience might not have been. Some of your audience might not have been born, but the amazing story where Hubble had a machining fault.
Yeah,
so
I was going to bring this up. It's a really good story.
Had a cataract. When it was first up there, the first images came back. They were horribly blurry. The team investigated what had happened, figured out in the machining process there'd been a fault, managed to design a fix that then the astronauts went up on the shuttle and inserted inside the telescope a pair of corrective lenses in a manner that was never part of the original design, and we get beautiful Hubble images. I mean, it's an amazing...
Hubble is basically wearing a pair of glasses.
Yeah.
Monocle.
Yeah.
Which was never in the original design, to squeeze in there, make work fit, and everything be fine, and they found a way. So it's a fantastic story.
There's an awesome documentary about like the making of the mirror for Hubble, and when they were grinding the mirror, it had to be so precise that they had to stop if somebody was on the road 2 miles away with a truck driving across. They had to shut it all down, the sanding of the mirror, because they had to get it so perfect. So yeah, very
spherical aberration. And
yeah, exactly. So very, very precise stuff. The last thing I wanted to touch on with this, and I don't know how deep we want to get into it. There's obviously been a lot of controversy about the naming of it. I've seen a lot of people complaining about that. Jason, any thoughts on that? It seems James Webb might have had some not too modern ideas about homosexuals or something
Well,
similar?
I can't get inside his mind. I don't know everything that was going on. I think that if we're looking for, well, now it was a little bit weird that they chose the name of the James Webb Space Telescope before it launched. So this was, to my knowledge, this was the first time that NASA had named a mission before it was actually operating. Normally what happens is that you take a mission, you launch it, once it works, then you name it. So for example, Hubble was originally called the Space Telescope. So the Space Telescope Science Institute was built around the Space Telescope. And after it launched, then they called it Hubble. Certif was the Space Infrared Telescope Facility that became Spitzer. Then you had, I don't know what Compton was before it launched. You had Chandra that also had another name. Fermi, the Fermi telescope was glassed, the Gamma Ray Large Aperture Space Telescope. It was glassed up until it launched and they renamed it Fermi. So when they named this one James Webb, that was a bit unusual. And it was kind of done, as far as I understand it, it was done as a way of like, there's no way that NASA would ever cancel a mission named after James Webb because he was, instrumental in getting people onto the moon. As far as like, all of these people are flawed. There's no person on the planet that doesn't have flaws of one form or another. And I think that waiting for that person to come, then the millennium will be ushered in, and it'll be a different world that we live on. So
I guess it's always difficult when we're looking at people who lived in a different age, and was he typical? Was he atypical of that time? It's all a bit.
Well, how many of these people were anti-Semitic? How many people?
Yeah.
If the Israeli,
I wouldn't want somebody to look back at sort of my moral qualms in 50 years, let's say, and.
But we don't know what's going to be viewed. How things are going to be viewed 50 years from now. Some of the things that are happening today. I can't believe that you let so many people live in homeless encampments. Look how terrible these things were.
Eat meat or whatever it might be.
Yeah, and so I think, if the Israeli Symphony Orchestra can play Wagner, I think some amount of grace is in order for people that don't live up to our standards. We don't know. I know that one of the names that was proposed as a replacement was like Harriet Tubman, but we don't know her opinions about a lot of these things either. The fact that there's less documentation doesn't all of a sudden make the person a moral superior in one form or another. So it's unfortunate that
it sort of got wrapped up in a bit of politics right at the end.
Yeah, I don't know that. I just, at some point, it's up to us today to be magnanimous.
Fair enough. The one thing that you sort of ruined for me on this, Jason, which was a very good comment when we were discussing this beforehand, was I was saying we'll get a load more of these beautiful, Hubble deep field pictures that people love to use as their screensavers, but won't they all be in infrared, so black and white, boring, horrible pictures?
We'll do a pretty good job of false color refining it.
Yeah.
So if you
just reallocate the frequencies to other colors and crack on.
Yeah.
There is a really, just to get people a flavor of what's going on. If you do a search for the Eagle Nebula Hubble Space Telescope visible light, infrared light, there's a side-by-side. There's a side-by-side image of the Pillars of Creation, which was a really iconic. I mean, I put it up on my wall when it came out.
Yeah, I've got it up. Yeah.
And it shows a side-by-side of here's what it looks like in visible light and here's what it looks like in infrared light. And you can see the difference. And it's just kind of the beginning of the difference because James Webb will be able to see further into the infrared than Hubble was able to.
So and we'll get some sexy pictures then.
Yeah, it'll be pretty gnarly. I mean, they'll boost the colors into the visible range. I have no doubt that the graphic artists will be able to produce something that is quite incredible. So you can see like the difference between here's what the clouds look like in the visible and they're totally opaque, which gives some information, right? You know what the optical depth is at certain wavelengths, tells you information about it. But then you don't want to just go back and take another picture of the same place unless you can get new information. And so the new information is what you get at the longer wavelengths, and you can see really how different it looks. Certain areas are just more exposed. You can see deeper into the features.
So brilliant. So that's going from the very, very large. Now, Jason, I want to go down, and Ramsey, I want to go down to the very, very small. So another interesting result that came out last week, I believe, was that apparently there are no sterile neutrinos. Jason, any thoughts on this before do you want me to give a little bit of an overview of sort of what's going on?
So this goes back to the LSMD experiment.
Yeah. You've always got like the best anecdotes and things for these, because you were usually, I think you were around there at Fermilab, potentially around this time.
So I was around at Fermilab. I was also, I did a summer internship because of how impressive I am. So I did a summer internship at the University of Washington when they were getting involved in a number of neutrino experiments, and it was right after this LSMD experiment came out. So I was working in neutrino physics with to the extent that an undergraduate student can actually do significant work in neutrino physics. But I was working in neutrino physics right around the time that the LSMD result came out. So Los Alamos National Lab, they did this experiment using a liquid scintillator. So it was an oil that they were using as their detector volume, and then they have a bunch of photomultiplier tubes around it. And they were looking at neutrinos, and they saw a signal for, I guess, oscillation, neutrino oscillations.
Yeah.
And other information came out with later experiments, I think Kamiokanda and Super K and things like this. And so the allowable range of standard model physics started creeping past the LSMD result. So the LSMD saw a signal, and so they have a region in parameter space where some new physics or some new particles.
I think they saw too many electron neutrinos in their beam than would be anticipated by standard model calculation.
And that implies some mixing. So they had a large mixing angle and a small mixing angle solution. They had these two islands kind of, well, it was like one island and an archipelago of regions in parameter space where this new type of neutrino, or where this effect would be seen.
Yeah.
Then other experiments came along and they started cutting into what the allowed range was. And eventually they passed it. Like they went all the way through the detection region of LSMD. And so now you have this problem. What did they see? What did LSMD see? Because it's not standard model stuff, because we've made all these experiments based on standard model physics. We've made all these other experiments based on standard model physics, and they don't reproduce the result. And so Fermilab in the early 2000s said, okay, we're going to do another experiment that would look specifically at basically this. I think it was another technique to look at the same regions that would have the same kinds of sensitivities that LSMD had that maybe these other ones didn't have. So I don't know the details of Mini Boon, which was what that was called. And I was at Fermilab when the Mini Boon results came out, and it was basically like, we found exactly the worst possible signal you could imagine, which was they didn't see zero signal and they didn't see a strong signal. They saw an ambiguous signal, which is like, that's the worst feeling in particle physics, in anything, is when you see a signal that's like, it's not statistically significant, but it's still there. And so they came back and they ran it some more, and then they built Microboon, which I guess is this one that where the results just came out. And it's all looking for, maybe there's a sterile neutrino. So that was kind of the promising mode, is that a sterile neutrino, it doesn't couple to standard model particles the way that the other neutrinos do. And so, but it's still produced in this one experiment. And so it's just a loss of something.
Yeah.
And
so the idea was that this would explain why we were seeing too many electron neutrinos, because
from 1995.
Yeah. So maybe the same
year as that Hubble image.
Yeah.
And the same year that the first exoplanets were discovered. So 1995 was a banner year. I think that was also the year that the comet Shoemaker-Levy 9 smashed into Jupiter. Man, what a time to be alive.
What a great time to be alive. So the idea was we were seeing this anomalous result in neutrino oscillations where neutrinos change from one type to another. 3 types of neutrino: electron, muon, and tau. We were seeing too many of these electron neutrinos, and one of the ways that we always fix things in particle physics, if we're stuck, is we go, well, that just means there's another field and another particle hanging around that doesn't interact with anything. So this is the idea of the sterile neutrino, and some of our some of our neutrinos might be oscillating to the sterile neutrino and back, and therefore we get disappearances or excesses. And we don't see these sterile neutrinos because they don't interact with the weak force. That's why we call them sterile. So if people want to go a little bit deeper, know a little bit more about particle physics, these would be right-handed neutrinos, which don't interact with the weak force compared to the left-handed neutrinos that we do see. So the idea was this weird new particle was hanging around in the background, and Microboon has done its experiments at Fermilab and found that, unfortunately, it doesn't look like this particle hangs around in the background at all.
So it became trendy for a while to think that maybe the sterile neutrino, if it was really massive, would be dark matter.
Yes.
Dark matter candidate.
Well, so this would be a perfect dark matter candidate as well, the sterile neutrino, because you've got something that doesn't interact via EM, so it's dark, but it is massive, so it interacts via gravity. But we haven't seen its interactions because it doesn't interact strongly or weakly or by EM. So you essentially have this sterile, dark particle which could be everywhere in the universe without us detecting it. So it becomes a really good dark matter candidate. But I believe there's a problem with that. It can only be some certain type of dark matter candidate, can't it?
Right. So it depends on the mass. So if it's got a mass that's similar to the other neutrino masses, which is not an unreasonable expectation, then it actually can only contribute some fraction of the dark matter, because these neutrinos, light neutrinos, move too fast. And so they would create puffy halos. And if you have a really puffy halo, then that's not what we observe, right? We observe dense concentrations of dark matter to form the galaxies. So if there was some other mechanism that made it so that the sterile neutrino was particularly massive, then it works as a cold dark matter candidate. So the dominant model for the history of the universe is lambda CDM, which is dark energy. Lambda is dark energy, cold dark matter. And neutrinos, if they are the mass of the standard model neutrinos, would be considered hot dark matter. And that creates more diffuse galaxy halos. And so the galaxies don't look the way that they're observed. If that's the only thing if that's the only game in town, then light neutrinos aren't a candidate for dark matter. But if it's heavy, then the things change.
But it looks like it doesn't exist at all. So it's back to the drawing board. And it would have been really nice because it would have been a dark matter candidate, which all these new sterile particles always are. So in particle physics, when most new hypotheses seem to throw out a dark matter candidate, and it never is that. So it would have been a good dark matter candidate.
Yeah. This is still the dark matter candidate for thinking people.
Yes, there you go. Yeah. And it also could have introduced.
So you better hurry and finish your sentence before we get.
You froze, Sam. You froze.
Oh, did I freeze? Oh, sorry. So it could have also introduced CP violation into neutrino oscillations. So it could have been a good dark matter candidate and helped us to explain why we get such a large matter-antimatter asymmetry in the universe. So it could have answered a lot of questions, but unfortunately, according to the analyses from Microboon at least, it doesn't exist. So
doesn't appear to be there.
Yeah, all those theories go out the window, and we have to think of some more new physics.
Jason, I thought you were showing off that you captured one neutrino in your washing up liquid bottle. But is Axion the name of a dark matter candidate?
Yes, indeed. So the Axion particle was actually named after this detergent.
No, surely. Are you serious?
He's got the best. Yeah. I told you, he's got the best anecdotes. Always got the best.
Yeah, so you can't get this detergent in the United States anymore, but you used to be able to. I think it was purchased by Palmolive. But if you go to Mexico, they still sell it there. At least they did as late as 2010. And so I went there and I saw it at the grocery store, and so I bought like a whole bunch of bottles of it.
Just because.
So Axion is a type of particle that was proposed to explain why there is no CP violation in the strong nuclear interactions. So if you just write down your theory, and under the assumption that anything that's possible is compulsory, like if it's possible to have an interaction, then it must exist, then the strong nuclear force should also have a CP violating aspect to it. And then that implies some value for, I think it's the electric dipole moment of the neutron, or I think it's the neutron electric dipole moment. fairly confident about that, but it's some
Yes,
particle.
I think that rings a bell. I haven't looked at it for a while, but I believe you're right.
And so you would expect to measure that. If there's CP violation, then you would expect to measure an electric dipole moment of the neutron of some number close to 1.
Yeah.
And so they went and measured it. The powers that be went and measured this dipole moment and got a value that is consistent with 0 and is smaller than 10 to the minus 10. And so the difference between 1 and 10 billion is sufficient to say, okay, something's going on here. And the solution that was proposed is maybe there's a new particle.
It's always the solution. There's a new particle.
So there's a new particle, and that particle, so this coupling that should be of order unity is actually a field that has 0 vacuum expectation value. And so the existence of this field drives it to a 0 value, and that's why it wasn't measured. And then now you have a new field, and if there are fluctuations of that field, so like vibrations, then in the language of quantum field theory, any vibration is actually a particle. And so you have a field, you fluctuate that field, you get a particle, and that particle has certain spin properties. And so it has an axiom or an axis about which it spins, and it's a pseudoscalar. So it has an axis about which it spins, and it needs to clean up the strong CP problem. Yes. And so a perfect candidate for a name would be something that's axial.
Axis and cleans up. Yeah.
And that cleans up the strong CP problem.
So and I'm guessing we're still, sorry, just to go on the neutrinos point, I'm guessing we're still detecting neutrinos in the same way as we've always been: fill a mountain with heavy water and wait for Cherenkov radiation to fly.
So microboon is, I believe, a huge vat of argon. So the neutrinos obviously streaming, billions streaming through it all the time, and then eventually you get an interaction between one of the atoms of the argon and the.
That's weird. Are they doing?
I think it's argon. When I read about it, I'm sure it was argon.
Okay, so if they're using it as a Cherenkov detector.
I don't know if they're using it as a Cherenkov detector.
Okay, so that's actually really interesting.
I'm guessing. That was my.
Okay, so if they because certainly a thing like this would not, you would have the Cherenkov, you'd have the photodetectors around the perimeter. So if they're not using it as a Cherenkov detector, then they're actually using it for a similar type of interaction of the experiment that caused this whole field to begin with, which was the Homestake Experiment in the 1960s, where they were looking for.
You had the interaction with was this the one with all the washing up liquid or the cleaner?
Yeah, the dry cleaning solution. They had dry cleaning solution.
Yeah.
And you add neutrinos to the mix.
Yeah. But it knocks something off, and then that something annihilates with something else, and then you get a photon. I can't remember the exact interaction, but that's the idea. Is you get like this cascade that produces light, and you can track the light back from your photodetectors to find out where the interaction happened.
Okay, so is that for this one?
I don't know. So I'm not exactly sure, but I believe it's something similar. I don't know exactly the inside workings of it.
The Homestake experiment used dry cleaning solution because it was a liquid form of chlorine. So you have chlorine atoms, and that's your target. And then you hit it with a neutrino from the sun. You hit it with a neutrino from the sun, and that converts it from chlorine to argon. It goes through this inverse beta decay thing. And so it turns it to argon. And argon, like the difference between chlorine and argon, as far as like their chemistry, is huge. Right, that's like one of the most corrosive gases that exists to one of the most inert gases.
And a noble gas, yeah.
And so then they would actually just chemically measure the amount of argon. They had a pump, and they would cycle through the dry cleaning solution, picking out the argon atoms. So it's pretty gnarly measurement if you think about the fact that you have this huge swimming pool sized tank of chlorine, and you're measuring single argon atoms.
And you won't get the same interaction from a muon neutrino because you can't get the cross coupling between electrons and muons. So you can get an idea of how many of each different type of neutrino.
And so this one, if they're doing argon, then they're probably, I wonder if they're doing the same kind of radiochemistry thing where now they're producing. Anyway, so the fact that they're going back to argon and not as a scintillator, so not as something that shines where the light can shine through it like they are with the water. The density of neutrinos is pretty high. They focus the beam directly into the.
Oh, okay. So it's not natural. They're using a source to switch down.
Yeah.
Right.
I like their tagline. So it says microboon, and it says driving new physics, NU physics, which for people in the know, new is neutrino. It's the Greek letter we use for neutrino.
Chemical symbol for neutrino.
Yeah, and it sounds like new. So driving new physics is I quite enjoyed that. I had a little nerds chuckle to myself about that one. That was pretty nice. So that's Micro Boon. We haven't found a new sterile neutrino, so we're still looking for the high levels of CP violation that explain the matter-antimatter asymmetry in the universe, and we don't have sterile neutrinos, so there isn't a fourth neutrino as far as we can tell. We're still stuck at 3 generations, and we still don't know what dark matter is. So
still know what dark matter is. So I have a future. There's still a future.
Yeah, there's still a rich future in particle physics and astrophysics for all you people watching who should be going into one of those two fields, as me and Jason would say.
I can confirm it is advanced liquid argon technology, which probably means they've applied machine learning.
That just sounds like a washing up liquid.
Yeah.
Okay, fair enough. We should mention, just before we go on to the next sort of topic, that it was COP26. Probably can't not mention it. Doing a science roundup of the month in Glasgow the last couple of weeks. I think it probably deserves, if we're going to talk about climate change and stuff, probably deserves its own hour, its own show. But Jason, Ramsey, did you take anything that you wanted to say away from what happened this week? It sounded like there was an awful lot of talk, an awful lot of promises as usual, but it all just descends in the media into this guy wasn't wearing a mask, or a load of people flew in,
big
and
shocker there.
That's too much carbon. It's
I'm too important to obey my own rules.
Yeah, it all just sort of descends into the media.
My quick tuppence worth. Yes, you've nailed it. The press just leapt straight onto private jets and people bringing their own vehicles and security versus.
But I'm gonna take my multi-million-dollar yacht that has 0 carbon footprint after I spend the multi-million. It costs like several people's lifetimes of carbon emissions to build, but once it's built, then there's no carbon emissions. So
well, it's like Bezos's rocket. He was going on about how clean his rockets were because they're fueled by hydrogen, but it's like, where did you get the hydrogen from? Was it electrolysis of water, or with lots of electricity?
Chemical reaction.
They should get it from very high temperature gas reactors. That's what they should get it from.
Well, or they get it from, where do they else get it from? Like methane?
Yeah. So it's steam reforming from methane and usually a natural gas burner.
So there's some CO2 along the way there.
Oh yeah, there's like anyone that claims that I have deep suspicions about any company even that claims that they have 0 carbon emissions. I'm like, yeah, I don't buy that. It depends on when you stop the integration.
I said it was nice. Ramsey, but you mentioned it this week. It's nice to see Greta actually being a kid, like getting filmed, dancing around at pop concerts and things, rather than people don't seem to be taking her as seriously this time, which is good. I want to hear from the scientists. I don't want to hear from.
It's better for her mental health.
Well, that as well.
To not be paraded around in front of everybody like that.
No, exactly. My other quick takeaways were. That heat pumps obviously are starting to become part of the vocabulary. So it used to be the case that only.
Which I'm still convinced. I've told you this. I'm still convinced they're magic, because the last calculation I saw was like efficiency of 800% or something, and I was like, hang on a minute.
Well, yes, you've read an interesting article about heat pumps there, but based on the same tech as your fridge or an air conditioner, transferring heat from one place to another with the application of some electricity along the way. So there's a lot of talk over here, basically, Jason, in the UK about trying to get a lot more heat pumps installed over the coming decades. And I think heat pumps will have different impact in different climates, basically, depending on
£10,000 grant for every home. I think if you wanted it, they were talking about at some point. I think it was just a pie in the sky suggestion, but that was.
So I don't doubt the feasibility, like the idea that heat pumps are more efficient. I'm like, that's fine. I don't have any reason to doubt that. I do have reason to doubt that they're actually better for the environment if you have to pay people to put them in.
Indeed, like ripping out loads of existing stuff to shove a load of new stuff in, as we just said, there's that immediate kind of transition period, which is very wasteful in general.
So it could be that maybe the cost is, I don't know how long they last. So if But if you take away the incentive and you just go off of here's a heat pump and here's my furnace or whatever, and if it doesn't make sense financially without taking someone else's money and paying for it so that you can feel good about yourself for installing it, then it probably is not better for the environment. But it could be better for the environment, and it's just that because it takes 20 years to recover the expenditure,
people don't go.
Fewer people do it. So it really comes down to if without the subsidy it makes financial sense, and the subsidy is simply there to give people an additional incentive to do it, then yeah, it works. But if there has to be a subsidy to go there, that subsidy, that's just that's hiding the carbon footprint somewhere else.
Yeah. And they're certainly not magic devices, I'm afraid, Sam. You can heat up a space with a heat pump using the outside air of the ground to a certain level. But if you want the room to be warmer, you're still going to be turning on a coil and heating the rest of the way to whatever temperature you want to reach.
Is this something where they send the air underground to?
Yeah. So yeah, exactly. I think the way that we'll probably end up using in the UK is that we'll bury the other end of the heat pump. And of course, in some places in the world where there is rich geothermal temperature already, then that's a great place to go and get heat from. But generally, that's not an area of the world where you need to heat up. It's normally where you need to cool down when you're sitting on top of a.
Certainly in Las Vegas.
Yeah,
certainly in Las Vegas. And I have a friend of mine who has one of these. I guess goes like 50 feet down or something like that. This is the same device. Where basically takes you from 45 degrees if we're going by Celsius, or 110 degrees, 120 in local temperature, like United States temperature.
Okay.
So it takes it from there to like 50 or something like that, which is the temperature a few meters below the surface. And so, yeah, I can totally buy that saves energy. And so, especially if you have a new construction, you're building a new home.
I think this is the big problem when you get these old sort of ramshackle, uninsulated houses. Like you stick the heat pump in, it just does nothing.
I would say that the fastest way to change, if you have old houses like this, to dramatically change their carbon footprint, is to spray a bunch of insulation in the attic and put weather stripping around. I mean, these are dollars.
You don't know about Insulate Britain, do you, Jason?
He won't have heard about.
You won't know about Insulate Britain. There's a bunch of nutters who. You're right. It is a very cost-effective and very efficient way to reduce carbon emissions from old housing stock, but because apparently we're not doing it fast enough, they're sort of sat in roads and almost getting run over all the time and screeching on the television over here. You might have seen it.
In the UK gluing themselves to freeways,
gluing themselves to the freeway, and then
I can imagine all the people they're convincing by behaving like that.
Well, you've summarized very quickly the last 3 months of frustration in this country. Well, exactly.
I mean, is it really that hard to? Because this is something that insulation makes sense like from the get-go. It's so much cheaper than building a new roof, for example. Insulating a house in the United States,
a solution,
maybe like $1,000 or something like that, which implies that it's already has a smaller carbon footprint than making like a new furnace. A new furnace is probably 3 times that much, maybe more. So just insulating a house, that's something where if people knew how quickly they would recover their money,
they just do it anyway.
I suspect that a lot of the houses are just like, I can't afford $1,000 right now. That's probably what's going on.
That is it. Yeah, there are
the upfront costs
to pay for it all. Yeah.
So that would be because it pays off so quickly. I mean, you'd pay it off in a few years, but it's an upfront cost.
The cost per carbon saved is it's the most efficient way of reducing the carbon emissions.
I think electric flight is going to be one of the really revolutionary things that will help with some of this stuff. So hopefully we will see. There's already been some advances in the last couple of years of, I think Rolls-Royce have just launched an aircraft that is an all-electric, effectively like an all-electric Cessna, so that can probably fly for an hour or two. So hopefully there'll be some things beyond heat pumps and insulation that are big advances to sort out some of this stuff, and as much electrification as we can get away with.
It's all going in that same direction of you need to decarbonize the grid and then make everything electric, isn't it? So
yes, you need to decarbonize the grid. Exactly.
So electric cooking, electric heating with heat pumps.
There's the way to do that works, and there's the way to do that makes people feel good about themselves, but doesn't work.
So this was the other silly story, Ramsey, wasn't it? This week in the UK, is that they had like the Liberal Democrats voting against some nuclear bill at the same time as whining on about COP26. So everyone sort of gets involved, and everyone obviously wants to tackle climate change, and then they're like, but no nuclear. So it's
that just means that they're not serious. Anyone who says those things and doesn't have, if there is a counter argument for nuclear that doesn't actually articulate it very well, because when they it's just too expensive, these are people who do not know what they either don't know what they're talking about, or they do know what they're talking about and they don't care, and they're using it to satisfy a particular political contingent, and they don't actually care about climate change. Because
there's a really, really good book called Sustainable Energy Without the Hot Air by the late great Professor David Mackay from Cambridge, and it lays out a lot of this, and he used to be an advisor to the government probably 15 years ago now, and it's a shame they don't all just get handed his book as soon as they become an MP. It would make a big difference.
I give a talk, and the example that I use is when just showing the energy density of nuclear energy. It's the difference between $5 and it's a factor of like a million. And so you've got $5 versus 5 million. It's a different force, right? It's a different binding energy. And so when you break it apart, it's a million times the binding energy. And so here's the difference. It's like I show them, you can go to the McDonald's and you can get a value meal for $5. Or for $5 million, you can buy this house, send your kids to this school, drive this car, and pay this celebrity chef to make this value meal for you, and still have retire with. The difference is so enormous. And another thing that people don't consider, because it would require forethought, and that's not really in long supply when it comes to political fluctuations or fluctuations in the local politics, is that we don't yet know what the waste stream looks like for an all solar grid or an all wind grid, or even a half and half grid. When you talk about the amount of solar panels that you have to replace every day to convert just the current use of electricity over to solar panels, not counting for the fact that now that it's more diffuse, you have to have more infrastructure around it. And when I say infrastructure, I mean like pylons, electric pylons to deliver the energy. Instead of having a 1 gigawatt plant that sits on a square kilometer, you'll have 1 gigawatt that's spread out over 10 square kilometers or 100 square kilometers. And now you have to wire that all up, right? It's not coming out of a single generator. It's coming out of this thing that's spread out. So then you have how long do those last? How many do you have to replace it? Not even counting for the fact that you have to somehow shift the energy from when it's produced to when it's demanded, which is not at the same time.
This was the big problem we hit when they were talking about the new developments have to be essentially zero carbon. It was supposed to be by 2016. That who is in charge of this? Is it the person who builds the house? Is it the person who moves in the house, and then when the solar panel on the roof fails and suddenly you've got a massively positive carbon house, are they on the hook to replace it? Or was it the original developer? Or is it now a tax write-off and the government has to replace it? Once you go to all these diffuse solutions, who's on the hook for this, and how do you get people replacing them quickly enough to maintain those standards? So this was the big problem we had when we were looking at this, when I was working for the low carbon engineering consultancy, was when you go more diffuse, who's in charge and who's going to pick up the tab for this? It becomes incredibly difficult. And so our idea was to have sort of a buyout fund for centralized schemes, right? Where instead of sticking a load of photovoltaics on a roof when you build a few houses or something, you have to pay a tax into a centralized fund. And then the centralized fund goes and puts up a wind farm somewhere else, which is a centralized solution for many more people, rather than having these little diffuse things everywhere. But it's a difficult problem to get around.
I do this calculation with my students every semester. is like, let's find out how many solar panels do you have to replace if we switch the United States over to purely solar energy. And I'm not against solar energy. And where I live, it's one of the things that is fairly viable because of how much sun we get in fabulous Las Vegas, Nevada. But the number of, you're talking millions, like it's hundreds of thousands of square meters at least per day, and probably millions of square meters of solar paneling per day forever. And so, you know, people talk about, oh, what are you going to do with nuclear waste? It's like, what are you going to do with a million square meters of solar paneling every day?
Yeah.
It's a waste problem that we haven't had to confront yet because we haven't gone through the full life cycle of a really full-size commercial power plant. Unless, of course, it's a hailstorm that destroys it for you. But 50 years from now, or even 30 years from now, we're probably going to have to start dealing with the waste stream that we're adopting right now with this utopian view that it has no, that it's like this green quantity. And
they're all going to be on the moon, the solar panels, by then, though, Jason. So don't worry.
Oh yeah,
it'll be fine.
I'm sure that'll solve it because there's definitely no erosion on the moon, given the dust that you see across the surface of the moon. Very basic erosion.
As you said, the electricity storage and transportation is challenging as well because our battery, we still need that next leap in battery technologies. Like lithium polymer batteries are not the cleanest things to make. It generates acid rain. So you've got this.
As long as it's the 10-year-old miner in the DRC that's getting all the cobalt out for you, what difference does it make, right? And because we in the developed world can offshore all of the environmental catastrophe to the developing world, and as long as we don't see it, then it doesn't exist because that would require thinking beyond just my own feelings.
Well, this is what I was saying with Ramsey. Is probably the best thing that we could do because we're quite clean relative to China is put some massive tax on bringing in, shiploads of plastic tap from China. So
almost like you could imagine having a human rights tax.
Yeah. But I don't think it's going to happen. But that might be.
And, I think it's a complicated business because if you look at, there are some stories of people who, like from Vietnam, for example, as they started developing. It's like they moved into a factory and it was terrible working conditions by our standards, but by their standards, it was much, much better. And it gave them upward mobility that they could then, the people going from the farm into the factory and then advancing up and, improving their lives. And then as their people's lives improves, then they demand more improvement. But that makes it more expensive. That's why it's more expensive to manufacture in the United States than it is to manufacture in China. It's not because the raw materials cost any different. Like these are global commodities, right? It's the same price in China as it is in the United States to get the raw materials. But the workers demand, the workers want to have a home. They want to be able to take their family on vacation. They want to have time off. They want to have all these things, and you have to pay for that, and that goes into the cost of labor. And that's where the difference comes. So as as one country elevates its standard of living, the cost of labor is going to go up, and as a consequence, the cost of goods is going to go up from those locations. I mean, but I definitely think that the world, the developed world that has the appropriate, and sometimes they need to be adjusted, but the appropriate environmental regulations on energy production, we should be leading the way and not drawing back from what I, in my mind, is like the patently obvious technological advances that should take place.
How are you guys doing for time? Because we've discussed kind of 3 really good topics there. I've got some more. I had loads from this month, little bits and pieces of stuff. Metaverse. We've got an eye. The tech billionaires have been up to more stuff. How are you guys set for time? Because I know you both got your own commitments.
I'm probably good for 5 more minutes if we want to round up one more thing.
5 more minutes if we want to round up one more thing. Okay, so we'll skip Metaverse and maybe we go and talk about a little bit about Elon Musk. So Elon Musk this month, he's been up to a little bit again, Ramsey, hasn't he? So he's had 12,000 vehicles have been brought back in for a communication error on his Teslas. So Teslas are still struggling a little bit. The self-driving's nowhere close. He's literally been taking the piss because the SpaceX, apparently the lavatory cable came loose, and they couldn't use the bathroom, or they won't be able to use the bathroom. I don't know what the status of that mission is now, whether they're on the way home or they're home. So they're
relying on nappies.
Yes, they have to wear incontinence pants instead. Little nappies and wee themselves on the way home.
Well, we all have to get used to it at some point. So
yeah, exactly. So there we are. So he's literally been taking the piss. What else has he been up to? And the big one,
I think an important. Well, I was just going to say an important one is that 12,000 car recall on the software.
Yes. Do you want to say something? A quick note on that?
Just that kind of about time. Let's see more of this. Tesla's test a lot of beta software on random members of the public, which is unusual and a very agile computer science way of approaching the car industry, which is normally a bit more adverse to risk. So it's good to see large recalls and software being fixed properly and cars being pulled in by Tesla. And I think this attitude is probably shifting because they're starting to become, they're under the spotlight at the moment for what's going on. There's some really, really interesting stats, and Tesla is a good example for me of like lies, damn lies, and statistics in many ways, because you get all of these quotes about how safe Teslas are and autopilot and stuff. But what's not really accounted for is that whenever a Tesla does go wrong, often a human grabs the wheel and takes over. And what's not being reported in all of the sort of number of hours without an accident is number of hours without an accident because a human took over before the accident happened.
Yeah.
And we will hopefully see a bigger shift towards what we really do need, which is the being a bit more kind of get the software right before shipping it, which isn't currently the ethos at Tesla.
Mm-hmm.
Indeed. And so the big thing, and I'm sure Jason has some thoughts on this as well, with Elon Musk, that really upset people I believe it was last week, was that he said that if somebody somebody put out a tweet, David Beasley, the director of the UN's World Food Programme, and he said that $6 billion could solve the current crisis in famine around the world, basically. And Elon Musk,
$6 billion donated by the world's billionaires.
Correct. And Elon Musk fired back and said, if you can prove to me that $6 billion will solve world hunger, I will sell all of my Tesla stock and donate it to the UN, and you can get on with your program of alleviating world hunger, as long as you have transparent accounting for this. So this upset a lot of people, and I think there's actually a little bit of nuance in the language. So I think the guy wanted the $6 billion to solve some current famine problem that's going on around the world, I guess, mixed with COVID, mixed with other, probably weather phenomena, these kind of things. And then Elon Musk has fired back thinking he meant the whole of world hunger. But it upset a lot of people because it always gets mixed in with basically, we hate tech billionaires. Give up your money and it will solve the world's problems, which is usually incredibly mathematically illiterate. I don't know if you have any thoughts on this, Jason.
I wouldn't possibly have a thought on this. So we did this.
When I say that, I mean, I know you will. So let's have them.
So this is something I told, it was a brief aside in a class. I'm like, look, everyone in this class wants to be an engineer. You have to know how to divide. There's this mathematical thing that's called division, and you can use it as a tool to determine whether someone is lying to you or is just stupid. Both of these things happen. Basically, my advice to anybody is when you see a headline that's like gets you all riled up, it's probably wrong. Life is a little bit more boring than that, at least.
And all headlines are designed to clickbait and get you involved and get you riled up.
Just one person could do all this by themselves if they only had some moral framework to work within. It's almost certainly wrong. And this is another example of that. So we did the calculation. All right. There was some fairly popular YouTuber who I won't name, but was mentioning how the world's poor, the bottom 50% of the planet lives off of $5.50 a day. And if Elon Musk, if we just, vaporized him and took all of his money, because, of course, the Tesla stock would stay exactly the same if he was somehow gone. And we could solve this altogether. And, maybe it was just a fraction of that, but let's say that it was like 50 billion or whatever. So you just take the number of people in the bottom 50% of that's 4 billion people. And I think it was 36 billion or something like that. So you do the math and you find out that everyone gets $9. So all of these people, all the bottom half in the economic strata of the world would get $9. And the next day they'd go back to $5.50 an hour. Anyone who thinks that solved anything is a complete fool. And so the general public has the math skills to do this. It just takes a little bit more thought about, like, what is this person telling me? And can I do this math myself? The answer is yes, you can do the math yourself. You can do this calculation yourself. And you'll find that almost all of these kinds of claims that are just totally wrong. And they're wrong in the worst possible way, because you don't actually solve the problem, which is economic development. You need local economic development. You need the person in, pick whatever country you're talking about, Namibia, to be able to have the means to provide for themselves. And it's not going to be by giving them $5 a day and like, oh, I feel good about myself. The same thing happened. There's a shoe company that is like, if you buy one of our pairs of shoes, then we'll give away another pair of shoes to a poor person in Africa, and then you can feel good about yourself. It's like, there are shoemakers in Africa. There are people whose profession is to take raw materials and make shoes out of them. And these shoes don't cost very much because labor is so low, but they cost more than free. And so congratulations, you feeling good about yourself puts this guy out of business. And now he is subject to your benevolence from now into the indefinite future, until you stop doing stupid things to make yourself feel good and allow economic development to take place locally in these economies. And so this is another example of people getting, okay, so yeah, everybody hates tech billionaires. We all hate them. The world would be a better place if we didn't have Amazon and Tesla. Okay, so yeah, we can all agree that this is true. So let's take all of their money, and let's say that we take all the money from every billionaire in the United States of America.
He's being sarcastic, by the way, I think. Yeah.
And, well, let's just fund the federal government. Like, we have this wealth tax. We all agree that we hate billionaires. We'll take all their money. We'll fund the federal government with it. So there are 600 billionaires in the United States. They have an average net worth of about $2 billion apiece. That's $1.2 trillion. $1.2 trillion is what we'll get from the billionaires. Okay. Now there's no more billionaires. Good. The world's a better place without them. And we funded the federal government for 1 year. Problem solved.
Yeah. So this problem's a little bit more complicated than just giving away. Maybe it could solve something, some local problem for a temporary period. But if we're talking about large scale change, it's probably not going to come from just soaking the billionaires.
So
did this chap David Beasley have a logic behind it? Was he saying that it was to do a particular, provide electricity?
So he said it could help 42 million people who he said are literally going to die at the moment. So I don't know if it was in a specific country or it was, under specific conditions which could be alleviated in the very short term by just, there you go, there's a loaf of bread, everyone.
Yeah, and I will say that the person who spoke from the UN was much more nuanced in what he was asking for.
Yes.
The reporter, it may come as a surprise that the reporters who are reporting on it,
it's all become sensational.
Yes,
are the ones who have no idea. Well, they're the ones that are causing.
To be fair, I think Elon Musk answered his own question, right? He was like, this David Beasley guy was like, can I have 6 billion to solve this specific problem for a short period of time? And Elon Musk went, well, this won't solve the problem of world hunger, which wasn't really the question that was being asked. It sort of got broadened out from there to, we hate tech billionaires.
How much time does Elon Musk have to address every time someone flags him as like the person who's capable of solving their
it'd be every day, wouldn't it? It'd be done pretty quickly, I think, if everyone.
It reminds me of, and one of the best ways to help with world hunger is to lift some of the COVID restrictions. so that food can get passed around more readily around the globe.
Yeah, it probably does have something to do with the COVID restrictions as well. It's a very specific short-term solution, I think. I was going to mention very quickly before we close, so to not be outdone, Jeff Bezos, very last thing. So Jeff Bezos has had a fun month as well to follow on. So he was speaking at COP26. He took William Shatner into space and then didn't really want him to speak, and then just sprayed him with champagne while he was sort of breaking down on the it was pretty bad. Shatner's sort of breaking down, saying how amazing it is, sort of talking about the overlook effect, you know, how people sort of get really emotional when they see the shape of the earth, and Bezos just sort of wandered over and was like, champagne now, and then just like hosed him down, and Shatner's just sort of stood there being like, yeah, okay. It wasn't great. He tried to sue NASA and failed because he was a bit salty that Elon Musk was and SpaceX were doing all the stuff with NASA. So that failed, I believe, yesterday. So I guess that's gone now. And the final thing I wanted to mention, because Ramsey flagged it up to me, is that documents have leaked that he's getting a new 417-foot long super yacht, which will be the largest yacht in the world. So apparently the previous one was called Super Yacht A. So here's a nice picture of Super Yacht A. And I believe they're about, what does the article say? That one's about, that
was 469. So why are you saying his is bigger? Is Super Yacht A being retired or something?
I guess so. It says 469 feet long here, doesn't it? By one of the world's largest. So maybe he's just getting one that's similar. The largest one is apparently this Super Yacht A, and he's getting one that's very similar in size.
It'll be better in some way, I'm sure.
I'm sure. 3 masts.
Better paid staff.
So I had to work out how long this was. Apparently it's half as long as the Titanic. So, which is an interesting stat. So,
but it's cool that it has another little super yacht following it around.
Yes.
Containing other things like the helicopters and stuff like this.
Does it have the help?
And the submarine. Because no one on their super yacht wants to
Batmobile.
Like the helicopter guy that just wants to talk about helicopters. You want the helicopter help on the boat over there, so that you don't have to bump into him.
It's like some of those. It's like some of those horrible Russian families I work with, where they're like, "You work for us, but we don't want to see you outside of the work. Like you can't come to dinner with us."
It's like children, right? Children should be seen and not heard.
Like you can't come to dinner with us. We'll put you in a reasonable level of, but you can't have the same that we have. So over there you go. I think it's basically the same idea, isn't it? You don't want Mr. Helicopter Man wandering around in his greasy overalls while you're having your mojitos or whatever on the deck. So he's up to that. People are obviously very upset about this again. And they're building that in the Netherlands somewhere. It's actually quite, I don't know if you can see the picture. You got this beautiful sort of super yacht with these polished wood floors that you'd expect to see in like Monte Carlo, and it's in some horrific Rotterdam shipyard with like, you know, scrawled graffiti everywhere and dark cold water. It looks very, very odd. But Jeff Bezos has had a very interesting month as well. So, you know, not to be outdone by old Elon. He's had a fun
so aside from his great hairstyle,
Jeff's got no hair.
I know, it's great. It's
of course. Now I see where we're going. Yes. So
I don't care about their super yacht. I care much more about when they like underpriced diapers to drive the online diaper store out of business and then took over the market. That I care about. Him getting a yacht. You know, if someone.
I don't really care. I don't really care about him getting a yacht either. I just thought it was quite a cool little story.
Amazon. I think in general the world's a better place because of Amazon. If it wasn't, we wouldn't use it. And I do, you know, it'd be nice. I would much prefer that there be more competition in the area and that they not do these kind of parasitic destruction of certain industries as they crop up. But, you know, if someone like saves the planet, the guy that invented the people that invented the COVID vaccines, if they get to retire to their own private island after it, then, so be it, right? Good for them.
I think that's probably a good place to stop, because we're done what, nearly 2 hours. There's some more stuff that I really wanted to get through, but we're kind of up against it on time. We didn't mention the new Boston Dynamics robots dancing along to the Rolling Stones. We didn't get to talk about more flying cars, Ramsey. The world's smallest.
More flying cars.
Yeah.
Next time.
The world's smallest eVTOL has got its application approval in Japan, so we might be moving a tiny bit closer to flying cars. I'll just put that link up so people can see it. Where's it gone?
I'd be interested in the battery-powered airplanes too. That I was kind of surprised. I thought it would be long way off before we had electric airplanes.
You're gonna have to send me. I
think it's probably a long way off before we get.
See that.
I think it's probably a long way off before we get electric passenger aircraft. This was a Rolls-Royce demonstrator platform that was basically like an electric Cessna. I'll see if I can quickly find it. But it probably has 45 minutes or an hour flight time. Let me see if I can find it.
That might be something. Certainly electric vehicles aren't going to be going across the Atlantic, but you might be able to get them within the UK or flight.
So it completed a 15-minute maiden voyage. Rolls-Royce's all-electric aircraft.
Yeah, that's longer than the record.
Getting there.
So.
Yeah, there you go. Right, you got to start somewhere. And
Better than nothing.
And then the final thing that I wanted to discuss, and I think Ramsey, we're gonna go through this beautiful video made by Mark Zuckerberg, where I don't know what he's doing with his hands and why he talks like a robot, but we'll go through it, which is his introduction to what Facebook are now calling the metaverse. So Facebook obviously
we need to talk about the metaverse.
Yes, we need to talk about the metaverse. Facebook obviously hit by a lot of scandals. Looks like it's trying to kind of change its name from Facebook to Meta. And also, Jason, looks like it's trying
Accenture.
Yeah, and looks like it's trying to invent basically the Matrix. So, you'll have your little avatar that you run around in Facebook all day. They tried to do it with Second Life, I remember, back in sort of the 2000s, and
that saved a lot of marriages.
Yeah, it sort of went along for a bit and then sort of died off. But the idea that you will spend all of your waking time in Facebook sounds like some sort of horrible, nightmarish dystopia. So maybe...
I was trying to think before we did this, if there's a single movie where everyone living in the virtual world
is a good
thing.
Yeah.
And I couldn't think of any.
It never is. Like Matrix, no, you're enslaved by the robots.
Ready Player Go.
Like Inception kind of all goes wrong.
Yeah.
Ready Player One, is not great. No, tends not to be a fantastic thing.
Real friends are better than virtual friends.
Well, quite. It tends to be a distraction from your real world problems. But Facebook seems to want to be in at the ground floor on virtual reality and augmented reality after sort of missing out on smartphones and that sort of revolution. So Ramsey and I might have a chat about that tomorrow, because it's a little bit sort of nebulous exactly what it is, but there's a lovely video where he shakes his arms around and talks like an absolute weirdo. So I'm sure we can extract some points out of that. Gentlemen, thank you so much for taking the time to chat about these things with me. Jason, where can people catch up with you? Are you still doing your excellent live streams?
I am doing my live streams, although with some proposal deadlines that are coming up, it will be a couple weeks before I get back to it. But by the end of November, I do live streams on science topics. We're moving into a whole probably 6 weeks or so of nuclear energy, because we just finished AP Physics, the AP Physics Plus, where we did kind of deep dive into the different topics there.
Cool. And that's Horizon Sci, right? I'll put the link down in the description over on Twitch.
Yeah.
So
and I have followed.
Go on.
I have a follower or two on Twitter. But Twitter is not really such a great platform for mental health, and so I'm not particularly active on it.
Yeah, I try to stay off as much as I can. I
delete as many tweets as I send, and so.
And that's Horizon Sci on there as well, right?
No.
Good. Ramsey, how about you? You don't really use the old twits either, do you?
Purely in the chat box of your live YouTube video, Sam. Other than that, I'm in my own private metaverse. So if people want to get a hold of me,
they can get
purely on a Friday once a month.
Weird little avatar of you, and we'll talk. Right, good stuff. So, gentlemen, thank you so much. Yes, Ramsey, I'll give you a shout about the metaverse chat, and Jason, we need to talk about Nobel Prizes and stuff at some point. So we'll get on with that.
Cool.
All right, good stuff, guys. Have a wonderful evening. Have a wonderful weekend, and let's chat again soon.
All right, sounds
Cheers,
good.
Jason. Cheers, Sam.
Good stuff, guys. See you in a bit.